We're going to solve this system of equations using Gauss-Jordan elimination. Our first step is to get our equations into standard form. Once in standard form, we can create our augmented matrix. So standard form would be 2x plus 3y equals 5 for equation 1. Add 3y to both sides. And for equation 2, 4x minus 7y equals 11. Our augmented matrix is going to be 2, 3, and then a bar, 5. That's 2x plus 3y equals 5. And our second equation, our second row, is 4, negative 7, 11. Now I want this first row to have a 1 in this position. So I need this to be a 1. Well, what I'm going to do to make that happen is I'm going to multiply by 1/2. So I'm going to multiply row 1 by 1/2. And I'm going to write what I'm doing to row 1 right off to the side there. So I'm going to write what I'm doing to row 1 right off to the side. So when I multiply row 1 by 1/2, I get 1/2 times 2 is 1, and then I'm going to get 3/2 and a 5/2. And then row 2 is going to stay the same. Now what I want to do is I want to get that 4 to be a 0. So I need to get that 4 to be a 0. You do this through adding and subtracting. So I'm going to multiply row 1 by negative 4, and I'm going to add it to row 2. When I do that, row 1 stays the same. Row 2, negative 4 times 1, so negative 4 times row 1. Negative 4 times 1 is negative 4, plus 4 is 0. Negative 4 times 3/2, negative 4 times 3/2 is negative 6. Negative 6 plus 7 is 1. Negative 4 times 5/2 is negative 10. Negative 10 plus 11 is 1. So all I've done is I've performed this green multiplication and addition, and my result is 0, 1. 0, 1, 1. Now we have just to get this number to be a 0. So I'm going to multiply. I'm going to multiply row 2 by negative 3/2. I'm going to be impacting this first row. So I'm going to multiply row 2 by 3/2, and I'm going to add it to row 1. Multiply row 2 by negative 3/2 and add it to row 1. Well, the bottom row is going to stay the same, but the first row, row 1, 0, I'm right here, 0 times negative 3/2 is 0, plus 1 keeps a 1 right there. And that's why it's important to fill below your 1 with zeros before moving to the next column. So you're going to get a 1, and then you're going to get a 0 right below it. So you're going to get a 1 where that red circle is, and then we moved on to get the 0 where the green circle is right below it. In doing that, we actually got a 1 diagonally where we wanted it, and then we could move up and get a 0 just above that 1. So negative 3/2 times 0 is 0, plus 1 remains a 1 in row 1, column 1. Then I'm going to take negative 3/2 times 1 is negative 3/2, plus 3/2 is 0. And then negative 3/2 times this 1 is negative 3/2, plus 5/2 is 2/2, which happens to be 1. And then this answer is 1x plus 0y equals 1, which means x equals 1. The second equation is 0x plus 1y equals 1, y equals 1. So our answer is 1, 1. And that's how we solve using Gauss-Jordan elimination. Here's another one that we'll try. Two x minus y equals 1, negative 6x plus 5y equals 3. We're going to create our augmented matrix, 2, negative 1, a bar, and 1, negative 6, 5, the bar, and then 3. Remember that I need to get this position right here to be a coefficient of 1. So I need this position first. So I need that coefficient to equal 1. So what will I need to do to get that to happen? I do that through multiplication or division. So I'm going to divide or multiply each item in row 1 by 1/2. That's going to give me 1, negative 1/2, the bar, and positive 1/2. The second row stays the same, negative 6, 5, and 3. Now I need, remember now we need a 0 right below that 1. This needs to be 0. We're going to do that through multiplication and addition. So we're going to multiply row 1 by positive 6. So 6 times row 1 plus row 2 will give us those additive inverses. 6 plus negative 6 will give us a 0, and it's going to eliminate that variable in the equation. So our first row stays the same, but our second row, 6 times 1 is 6, plus row 2 is negative 6, which gives us a 0. 6 times negative 1/2 is negative 3, plus 5 is 2. 6 times positive 1/2 is 3, plus 3 is 6. So let me show you what we're doing. So I'm taking this 6, 6 times 1 is 6, plus negative 6 gives us this 0. 6 times negative 1/2 is negative 3, plus 5 is 2. 6 times 1/2 is 3, plus 3 is 6. Now our goal is to get a 1 in this position right here. So remember, we do that through multiplication and division. So we're going to multiply row 2 by 1/2. So row 1 stays the same, 1, negative 1/2, positive 1/2, and row 2 is going to become 0, 1/2 times 0 is 0, 1/2 times 2 is 1, 1/2 times 6 is 3. And we need this negative 1/2 to be a 0. So if I multiply row 2 by 1/2 and add it to row 1, it's going to work. So row 2 stays the same, row 1 is going to change. So 1/2 times row 2, 1/2 times 0 is 0, plus row 1 keeps the 1 right there. Let me grab this guy back. 1/2 times 1, 1/2 times 1 is 1/2, and then I add it to row 1, 1/2 plus 1/2 is 0. So there's going to be a 0 right here. Okay, let's do that again. 1/2 times 3 is 3/2, plus this 1/2 is 4/2. So 1/2 times 1 is 1/2, plus negative 1/2 is 0. 1/2 times 3 is 3/2, plus 1/2 is 4/2, which is 2. So x equals 2 and y equals 3. Being able to go through this process just really improves our critical thinking skills. Therefore, we're going to practice with an example that has 3 variables, just to get our brains really well exercised.